Hello, today we will discuss about uncertainty principle and some of the numerical problems related to this. First, the mathematical expression. The simplest way to express the uncertainty principle for the quantum mechanical particle is del of x, del of px is equal to h, where x is the uncertainty in the position. So in a certain region we try to find the quantum mechanical particle. The average value, the statistical average value of this position is given as del of x, and along with this the momentum within a certain region, the uncertainty in the momentum is represented at del of px. So we are considering one dimensional moment of the quantum mechanical particle. This is equal to h. But for advanced mathematics it is showing that the del x, del of p, del of px is greater than equal to h cross by 2. So actually h is the Planck's constant, is in the order of 10 to the power minus 34. So now if you divide it by 2 of pi, that order will not differ that much. So for simplicity we can use either this formula, or if you want you can use this particular relation for solving the numerical problems. So it shows that mathematically we have a relation x and p in between position and momentum. So it is showing this thing that it is impossible to measure position and momentum simultaneously with uncertainty del x and del px that multiply to be less than h cross by 2. It always be greater than h cross by 2, and at least this should be equal to h cross by 2. This cannot be less than 1. So it's a mathematical relation. So x value and y value, if you are multiplying this thing, this should be equal to h cross by 2, cannot be less than this one. Now by considering this particular relation, we are trying to find some of the numerical problems related to this. So the first problem I am considering. So we are considering the position of electron in an atom is measured to an accuracy 0.01 nanometer. Then we need to find what is the uncertainty in velocity. And the next part, if you have the velocity, we need to find what is the kinetic energy. So the first thing is given is the uncertainty in the measurement in position. So del x is given as 0.01 nanometer. So you are converting in meters. Now by using the formula del x, del of px is h cross by 2. So we are considering the minimum condition, this is equal to. So I am considering h divided by 2 into 2 pi. So this becomes 4 of pi. And as we are considering the momentum, so this is mass into velocity. So I have taken velocity uncertainty and mass is divided by this one. So electron mass is given as 9.1 into 10 to the power minus 31 kgs. Okay, and obviously this will be multiplied with x. So it is divided by x, del of x, and del of x, the uncertainty del of x is given. So when you are simplifying this one, this value comes 5.76 10 to the power 6 meters per second is the velocity. Now the next part, so the answer of A is given here. So now we need to find what is the kinetic energy of the system. So you all know from our school days idea that kinetic energy is represented as half m velocity square. Now you know the velocity uncertainty. Square of this one multiplied with its mass of the electron and multiplied with half. So this gives you in the order of some 1.53 10 to the power minus 17 in joule. Now if you divide it by electron charge, this will give you the thing in electron volt. So from the uncertainty principle you are able to find its velocity and the kinetic energy uncertainty in the system. Now move to the second problem. Now the second problem is given as if the uncertainty in the velocity of two particles A and B, we are considering two particles, obviously both are quantum mechanical particles, and their masses are given. One is in the order of 10 to the power minus 27 kgs, another is in the order of 10 to the power minus 31 kg. And it was mentioned that the velocities are same. So then what is the uncertainty in the position? So given its masses are given, and also mentioned that the velocity uncertainty, they are equal. So del of VA and del of VB, they are equal. So as per the uncertainty relation, so del x and del px for A and B, Okay, and in the minimum condition this must be equal to h cross. So we need to find the ratio between this particular thing. So x and m, xa and ma, xb and mb. So find the ratio. X by a, this must be equal to mb by ma. So the ratio in the uncertainty in the position is given in the order of 10 to the power minus of 4. Now we are moving to the third problem. So again the same type of problem here. So the uncertainty in the position for measuring electrons. So where this is given, its particle is moving with a velocity 300 meter per second with an accuracy of 0.001%. So the velocity is given and the percentage of accuracy is given, and you need to find what is the position. So the uncertainty in the velocity must be calculated first. So what is that? This is 300 into 0.001 percentage. 0.001 percentage. If you simplify this one, it comes in the order of 0.0003. This is the uncertainty in the velocity. Now use the relation del x del p. Del x del p, the relation, the momentum can be given as mass into velocity. Then rearranging this one. So x is given as h cross divided by 2 into pi. Actually this becomes 4 into pi. Then the mass of the electron, this part is the mass of the electron, and this is the velocity uncertainty. Is the velocity uncertainty. If we put these values, it comes, its position is in the order of 10 to the power minus 2 meters. Now we have the fourth one. Now in this case, what we have taken a position of an ion. It's a chloride ion, this is given. Now it is given as the maximum error in this case of 1 micrometer. So you are measuring position. Just imagine you have a chloride ion. You want to determine its position, and here the error in the system is in the order of 1 micrometer. Now the mass of the ion is given. So obviously you need to find what is the velocity. So the uncertainty or the error in the system. So del x is given. Del x is in the order of 10 to the power minus 6 meter, micrometer. And again the relation x and px, h cross by 2, that the minimum one, this should be equal to. So del of v, the uncertainty in the velocity, is equal to h cross divided by 2m into delta x. So put the values, and it comes in the order of 10 to the power minus of 4 meter per second. Now the last one, we have an electron in a molecule, travels at the speed of say some meter, 40 meter per second. The uncertainty in the momentum delta p of the electron is in the order of 10 to the power minus 6 of its momentum. Just remember this one, it is given as 10 to the power minus 6 of its momentum. Now compute the uncertainty in position. So del x need to be found. So the mass of the electron is given. Now the important part is the uncertainty in momentum. This is given as 10 to the power minus 6 of its momentum. So first you need to find what is the momentum in the system, and then the uncertainty. So the momentum is mass into v, mass into velocity. So the mass is 9.1 into 10 to the power minus 31 for the electron, and it moves with a velocity with a speed of 40 meters per second. So the mass into velocity gives you the momentum, and the uncertainty, then this is in the order of 10 to the power minus 6. So multiply those ones. So this gives you the uncertainty in the momentum. Now we need to find what is the position uncertainty. Use that formula, use that relation, considering the minimum one. So del x is given as h cross by 2, that means h divided by 2 into pi, that's the mass of the electron, and the uncertainty in the actually you can consider uncertainty in the momentum. So this is the mass, and this part is the uncertainty in the velocity. So overall this blue section is the uncertainty in the momentum. So simplify this one. This gives you the position uncertainty of the electron within that region, which is moving with a velocity 40 meters per second. Thank you.